episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So you remember last week when I said if I came up with any kind of Ansible playbook to automate the install of some service I'm running in my home lab, I would update you all? Yeah, well, that didn't last very long. So we got some updates coming there. And also, I have been kind of keeping a secret from you guys here for a little while when it comes to my Pokemon game, home lab, and just development in general. So we're also going to touch on that in this episode. So we got a good one for you today. And if you saw the title of this week's episode, you might get a little bit of a sense on what could potentially be coming down the pipe. And just as a heads up, if you have not listened to the episode we did where we interviewed the Dr. Frankenstein of Max, aka DOS Dude 1, you'll definitely want to check out that interview. You can by all means, listen to it after this one, but it'll definitely help give you some context for what's going on. So I'll try to remember to have a link to that episode in the show notes so you can find it. But with that, let's get into this week's trivia question. So last week we talked about Ansible, and part of that was that Ansible uses YAML to define its playbooks. But what does YAML stand for? And YAML is spelled Y-A-M-L. And a little bit of a hint here, the ML does not stand for machine learning. So just thought I'd give you a little hint there. So that is this week's trivia question. Now let's move right on into this week's cybersecurity tip. So there was a little bit of a stir going around the internet. So apparently, with the update to iOS 17.5, apparently some people were seeing photos that they deleted showing up again in their photo library. And it's not like the photos were showing up in their recently deleted album, because once you delete a photo on your iPhone, or I don't know if anyone's still using an iPod Touch, or I don't even think they're supported anymore. But when you delete a photo or video, it goes into your recently deleted folder for, I believe it's 30 days. And then after those 30 days, it gets deleted. So we're not talking about photos showing up there. We're talking about photos that people had deleted like 5+ times. I think there was one story about 10 years ago. Like photos that have been deleted a long time ago and should have been long gone. Potentially photos that weren't even deleted on their device that they currently have, but a previous device, and them showing back up. So let this be a kind of a wake-up call to everyone that just because you delete something does not mean that that thing you think you deleted is actually gone, because that's not how deleting things works. Because when you delete something, all you're doing is you're basically telling the operating system, I don't care about this thing anymore. You don't have to worry about it. So the operating system's like, okay, cool. I'll just basically set that space that file is occupying as free, so it can then be used by some other file. It doesn't actually go ahead and delete said file. Now, there are ways that you can securely delete and actually erase data. So, for instance, there is one method that is used where you essentially take a drive and you go through and all of the, ones and zeros on the drive. You just set them all to 0 and basically overwrite the drive sometimes multiple times, going over multiple passes, and just overwriting everything to ensure that all the data has been completely destroyed and erased. In those cases, then yes, the data is gone, but just simply pressing delete or deleting something does not actually get rid of it, and especially when you're dealing with the cloud, aka someone else's computer, because you don't have control over if they are actually deleting your file, number one, and number two, actually erasing the data and setting it all to zeros and, nullifying it like we talked about earlier. So I don't know if there has actually been a explanation for what's going on and why this is occurring, but my assumption is the photos that were coming back were at one point in time uploaded to iCloud, and then there was some kind of issue with iOS 17.5 that caused some kind of sync error or something with the iCloud, and then those photos that were supposedly deleted got re-added to the device because they were still in iCloud for some reason. So this just goes to show you that just because you say you want something deleted and it is deleted doesn't mean it's actually gone, because you can almost bet for various reasons cloud providers generally aren't going to be deleting your data. And if they do, there's a very strong likelihood that there is a backup of that data somewhere else, with all the redundancy and backups that they are no doubt doing. So in the event they say have a drive failure or a complete server failure, they can easily roll back to a known good spot and have good backups that they can revert to. So yes, let this be a word of caution that before you upload anything to the cloud, you make sure that you'd be okay with it being there forever, because chances are it's going to be, even if you think you actually deleted it. So that is your cybersecurity tip for the week. Now, we got a decent amount of things to talk about in regards to what I've been up to, so let's move right into what nerdy stuff have I been up to this week. So before we touch on some of the Ansible shenanigans that I got up to, let's first talk about some of the home lab shenanigans that I got up to. So this week, I rearranged my server rack. So we touched on last week that I have just a 15U rack, which to some of you that could be absolutely enormous, and to others those are rookie numbers and I need to get a bigger rack. And if you're in the latter category, I completely agree. But as I mentioned in that episode, whenever it comes to adding new hardware or wanting to put something in the rack, it's like this game of Tetris, or I'm basically doing gymnastics, trying to figure out, okay, how can I move these things around so everything will fit? And this week I was adding a couple, not really adding new device. Well, I guess I technically was, but the main goal was I had freed up some space in the rack since I had offloaded a server. You may recall my old network attached storage server, or my NAS, was a Dell R510, and I ended up giving that to a friend of mine because they could make use of it, and of course I wasn't using it, and it was just sitting there in my rack doing nothing. So I was like, hey man, if you want to use it, it's all yours, take it. So he took it. It's off to a new home, going back into use. So definitely happy to see that. But that means that I have some extra space in the rack that can be used. And in all honesty, I really didn't do anything special. Like, I didn't add a new server in there. Pretty much I just put stuff in the rack that I wanted to be in the rack all along, just never really had a spot to put it. So I did some rearranging, mainly taking a old rack shelf I had just sitting in the closet, took that out, put it back in the rack, and moved my Dell 5050 mini tower, I think is the actual name for it. Move that down to the bottom, put it on that shelf, and then that freed up the shelf that Dell was on. So then I just kind of threw on like the mini PCs that I had to actually give them a home within the rack, rather than just kind of being off on the floor. Now, I didn't actually get them all cabled up and everything, because after I did this moving and shuffling around, I realized I didn't have enough Ethernet cables. So in order to actually hook them up, I'll have to get some more Ethernet cables. But it's not necessarily a huge loss or anything, because it's not like those mini PCs were ever really powered up in the first place. They kind of just occasionally get turned on. But part of the reason why they, I guess, occasionally got turned on and not consistently on, in part, was due to the fact that they didn't actually have a home in the rack. They were just kind of stacked on the floor. So they weren't, constantly plugged in and into the switch and into power, so having to go through and doing that was kind of a roadblock. Kind of similar to why I was a little hesitant to use my AI capabilities with my the large language model and stable diffusion that I set up, because in order to actually use them, I had to swap around some fan control stuff on my Dell R620, and doing that was kind of a pain. So then, of course, I decided to actually get my act together and write an Ansible script to do it for me, and that worked beautifully. So, just removing those little roadblockers, but that was kind of the main things in regards to moving things around. Now, speaking of Ansible, great segue right there. I mentioned last week about if I came up with any ideas to automate the install of some kind of service or hosting something with Ansible to make it recreatable, I would update you guys. And I have an update for you already. And no, I didn't plan that. It was just kind of, I don't know if necessarily spur of the moment is the right word, but it just kind of came up within the past week. So what am I talking about? So I run a service called Guacamole. And if you're unfamiliar with what Guacamole is, it's basically a remote management type software. So basically what it allows you to do is it allows you to RDP or VNC or SSH, or basically remotely log in to various services on your network. Now, I don't really use the SSH functionality because I can just use a terminal for that. But if I ever want to remote into a system and actually get a desktop interface, then I'll just generally go through Guacamole to do that. And it works great. My only, I guess, annoyance I have with it, which this is probably in part my fault, is how it's installed. And originally how I installed it was, I believe I basically installed it, I don't know if from source is the right word, but basically installed it on the machine itself and not through any kind of like package manager. So updating it was always a royal pain. Whenever I tried to upgrade the operating system it was on, which I believe is still Ubuntu 20.04, the service would just stop working. Like, you could still log into Guacamole, you just couldn't connect to anything, which was really annoying. So there were issues with it. Like, it still worked, but making sure that Guacamole itself was updated, it was just kind of a hassle. So I've been wanting to update how Guacamole is installed for a while now. It's been something I've been thinking about for at least a few months, if not more than that. And this week I kind of, stumbled on the idea of, why don't I just do this with Ansible? Well, I guess to take a step back, I had wanted to install it through Docker because if you do it through Docker, it's easy to just, bring the container up and down. And if there's any changes, you can easily bring it up and down and, import those changes. And it's because everything that it needs is packaged within the Docker container. You don't really have to worry about the underlying operating system, so it makes it a lot easier to update it without breaking things. So that was kind of the main reason why I wanted to kind of do the switch in the first place. I had just never really gotten around to actually implementing that. So this past week, I started working on creating a playbook that will configure and set up Guacamole to run it with Docker Compose. So I guess the key differences there with Docker versus Docker Compose, they basically work on the same thing. Just Docker Compose takes your potentially massive command line argument and puts it into a more readable file that you can nest multiple containers that all kind of can work together, in the same file, and you can just run Docker Compose up and it'll bring everything up. Docker Compose down, it'll bring everything down. And then you can do other things too, like build if you need to actually build any containers. And there's a lot of cool stuff you can do with it. So I wanted to get that implemented. So right now, as of the day I am recording this podcast, which is on Thursday, I have it basically working. Like, it's to the point now where I can run the playbook on either Arch, Debian, specifically Ubuntu, since that's what I was testing on, and Red Hat, and get a fully working instance of Guacamole running in Docker. And that is honestly, I was super thrilled about that because that's something I've been kind of wanting for a while, and having the ability to run on basically any kind of Linux distribution I want was definitely a massive win. And one thing that it was kind of something I added on during the development, so, good old scope creep, was basically allowing you to dump an existing Guacamole database to import into the new version. So how it's currently set up is it natively installs MariaDB, basically an SQL database for the backend. So it doesn't run any kind of SQL database in a Docker container, which I have seen a decent number of Docker Compose files doing it that way, but that's not how I elected to set it up. In part, I guess, due to how I currently have it configured, which is installed natively, so it has its own native SQL backend. So basically how this works and how I configured it to allow you to dump the existing database is it'll essentially log into your existing Guacamole instance, dump the SQL database into a .sql file, and then it'll import that into your new host that you want to install Guacamole on, import that database, and then it's like you're in the same install, which is honestly super incredible. So that's basically kind of how Guacamole works. So it stores everything in a MySQL database, while your connections, credentials, all that good stuff, it just gets stored inside the database. So now, like I said, it's not perfect right now. There still are a few things I want to clean up in regards to how things are done and kind of some of the YAML itself. So it's not quite done yet, but I'm hoping to have it wrapped up fairly soon. And this is something that will be going up on my GitHub. Technically, it's already there, but right now I just have it as a private repository while I was having it not in a functional state per se, and just kind of going through the development process. But that will be there. So if any of you want to install Guacamole and all you want to do is just run one command and do it with Ansible, you will be able to do that. So I was super happy to get that up and running and working, but like I said, got a few little tweaks to do and it will be good to go. Now moving on to, I guess, the secret that I have been keeping. So like I mentioned, this will, you might want to refer back to the interview we did with DOS Dude 1, since it will touch on things. But so as you all know, I have been working on creating my own video game, basically trying to recreate my own version of Pokemon from scratch. Now, up until this point, I have been exclusively building it for x86 architectures. But recently, I started work on getting my game to build on Apple Silicon with a DTK. And when you hear a DTK, you're thinking, wait, developer transition kit? But of course, when I say Apple Silicon, we're talking the M series chips, and totally not an actual Apple developer transition kit from Apple that developers had to apply for, pay, and then return to Apple back in 2020, which then Apple shipped all those devices off to be destroyed and had the logic boards drilled and cut to cause a short in the board layers to keep them from booting, only to then for me to somehow get a hold of one and then file down the cut to clear the short, resolder all the missing capacitors, resistors, pads, ripped off traces or any other knocked off components, remove the underflow that was missing from the NAND chips and replace them with new NANDs from an iPad Pro. But then, of course, you can't forget the step of reprogramming said NANDs in the first place with a NAND programmer, only to then transplant said board into a 2018 Mac Mini case with a power supply and an M1 Mac Mini I/O shield with antenna to fully restore said DTK into working order and using it. Now, obviously, that is a ton of work, so don't be silly. Now, I am not crazy to do something like that, but as you might have guessed from the topic of this episode, there is someone who is. And if you follow DOS Dude 1 at all on YouTube, you will most certainly have seen a video that he posted within the past week or two, maybe week and a half, on completely restoring a destroyed Apple developer transition kit to completely working order. And I, being a good friend of DOS Dude 1, was lucky enough to get my hands on one of the DTKs that he managed to repair, and I was very thankful for him for a few reasons. One, because the DTK is absolutely fantastic, as we will see shortly with some of the testing that I've done with it. And two, it is by far the rarest Mac that I have ever owned and probably will ever own, because up until this point, I would say the rarest Mac I've owned is probably the Xserve RAID, because I don't see a ton of those around. It's definitely between the Xserve RAID and the Xserve. I also do have a black MacBook, but I don't think those are necessarily as rare, although I don't know, maybe they are becoming more rare. Regardless, the DTK is hands down, it's not even a question anymore. So now let's actually get into the DTK itself and some of the cool things about it. So first off, if you've ever tried to do any kind of remote monitoring on an Intel Mac, one of the most annoying parts of it is you cannot run it headless. So basically what that means is if you don't have a monitor plugged into the Mac, you can't get a remote display and the Mac won't even boot. So it is rather inconvenient. So in instances where I do have headless Macs running, specifically my Xserve, what I have to do is plug in one of those like dummy display connectors. So I think I have a dummy DVI connector just plugged in to one of the DVI ports in the video card in order for it to actually boot. But the nice thing about the DTK, and from my understanding, all Apple Silicon Macs, is this limitation no longer exists, which is absolutely fantastic and glorious, because now I have my beautiful DTK sitting in my rack with the rest of the mini PCs, just fully headless, and it is beautiful. Now, another thing that's also really nice about the DTK, and in all honesty, any Mac with Apple Silicon, is the power efficiency. And the DTK is no different because, after all, it is running an A12Z chip, which was from the iPad Pro. And this thing I had plugged in to the wall with my kilowatt, and the max power I could pull from it while running code, compiling code, being fully maxed out on the CPU was 30 watts from the wall. So let that sink in. The DTK was compiling code, fully maxing out the CPU, and it was only drawing 30 watts from the wall. I have computers that draw way over that by just idling, doing nothing. Specifically the hypervisors, although you could argue that they're not technically doing nothing since they're running virtual machines, but you could also argue they're doing nothing because the virtual machines aren't really doing anything. Point is, the DTK doesn't draw a lot of power. Even when it's idling, like doing absolutely nothing, I think I clocked it at around 8 watts, which kind of tracks because one quirk with the DTK, which I know from having one and also from Apple's own documentation, is the fan. There is no fan control, okay? There is absolutely zero fan control. The fan just runs at a constant speed. Now, this is, in my opinion, not a bad thing for a couple reasons. One, it's honestly not all that loud, although in fairness, this is me sitting in a room with a server rack running, so of course I can't hear the thing because I hear the server fans. But even in the times where I didn't have it in the room with the server rack running, the fans still really weren't even that loud. Like, I have laptops that run at idle that are louder than this DTK. So that's just one thing. Like, for instance, another anecdotal piece of evidence, my 2012 Mac Mini under max load is an absolute screamer when it comes to the fans. And the DTK under max load isn't even warm to the touch. Like, the aluminum itself on the case feels cold to the touch. Whereas on the Mac Mini, it's quite warm and the fan is screaming. So, but getting back into the power draw though, at idle on the desktop, it was pulling around 8 watts, which, like I was kind of mentioning, this honestly tracks to what I would expect because the M1 Mac Minis, I don't have one, so I can't, verify this, but from what I've heard and from what I understand, M1 Mac Minis idle around like 4 watts or so, and seeing how close the A12Z and M1 are and seeing how similar they are, this honestly kind of checks out because if you factor in the fact that the DTK has a fan that's spinning at a constant speed of roughly about 50% of its fan speed is kind of my understanding. That would easily account for maybe like 2 or 3 watts, which then if you subtract that from the 8 watts that it draws from the wall, then that kind of puts it in line with right where the Mac Mini is. So speaking of performance, we talked about, the idle performance. We talked about how much power it draws from the wall when it's compiling code. So let's get into how does it actually compile code. So as a benchmark, I took the decompilation of the Pokemon Emerald source code and compiled that to create the GBA ROM file that you could then put on an actual Game Boy Advance and play the game. So I compiled that source code on both the DTK and my Mac Pro. So for context on the specs here, the DTK, or the Developer Transition Kit, has an A12Z CPU and system on a chip, SoC, and it has 16 gigs of RAM. The Mac Pro, on the other hand, has two X5680 Xeon CPUs that are both 6-core and 12 threads for a total of 12 cores rather, and 24 threads with 48 gigs of ECC RAM. So, and that's compared to the DTK with the A12Z that has 8 total cores, 4 performance, and 4 efficiency. So the Mac Pro definitely has a significant advantage when it comes to CPU cores. So I compiled the source code and found some rather interesting results. So I ran the compile on five different occasions. I ran it 5 times and got the average. And the way I ran this test was I wrote a Python script in order to compile the code. Basically what it does is it starts a timer, compiles the code, and then stops the timer and gives you a printout of how long it took to run the code, or compile the code rather. So the DTK on an average, it averaged 1 minute 21.4 seconds to compile the Pokemon Emerald source code, where the Mac Pro took 1 minute 57.7 seconds to compile the source code. So the DTK was under a minute and a half, and the Mac Pro was basically at 2 minutes. So if you're crunching the numbers here, the DTK compiled the Pokemon Emerald source code 30.8 times faster than the Mac Pro, which is kind of insane. Now, I'm not 100% sure if the compiler had anything to do with it. There's a chance that it potentially could have. So if you're unaware, the Game Boy Advance uses ARM as its CPU architecture, and seeing that the DTK and Apple Silicon is also an ARM-based architecture, not entirely sure if that's where the potential benefit comes, because as we'll see in this next test where I try to compile it against my Pokemon game that I'm writing, the performance delta wasn't nearly as high as it is in this test. But there's a couple potential factors for that. One, like I mentioned, is the architecture difference, and two is the fact that the length of the compile is a lot longer on the Pokemon Emerald source code compared to my video game. But with that said, let's move into the video game. So again, I did 5 different tests to get an average. The DTK took 4.75 seconds, and the Mac Pro took 5.87 seconds. So both obviously didn't take all that long. But if you're doing the math at home, the DTK was still 19% faster. So it's definitely a fairly significant increase. Of course, when you're on these small scale of numbers, it's not necessarily going to make that big of a deal. But if you look back at the Pokemon Emerald compile time, I mean, you're talking like over 30 seconds worth of difference in the compile time. And while those numbers are impressive, like, don't get me wrong, the fact that this little DTK with only 8 cores, only 4 performance and 4 efficiency, running an iPad chip is able to beat the Mac Pro, the beast that is the Mac Pro, while that's impressive by itself, that doesn't even tell the full story. Because, like I mentioned, when the DTK was doing these compile tests, it was maxed out at 30 watts, 30 watts under full load. And spoiler alert, the Mac Pro pulled 11 times that much just idling on the desktop. Yes. So the DTK doing real work was pulling 30 watts, while the Mac Pro doing nothing just on the macOS desktop was pulling 330 watts. So what this means is I could have an entire farm of Apple DTKs chugging away compiling code, and if I had 11 of them, they would only be drawing as much power as my Mac Pro doing nothing. Which is absolutely mind-blowing when you look at these performance values and just how much the DTK is able to outperform the Mac Pro. But the thing where it gets even crazier is because while the Mac Pro draws 330 watts at idle, I clocked it at an average of around 572 watts, so just shy of 600 watts during one of those compile tests, and it peaked at just shy of 700 watts at 696 to be specific was the highest that I clocked it at. And this is again through my kilowatt that I was using. So the Mac Pro not only drew basically 700 watts peak, an average of just under 600 compared to the DTK's 30, but it also got the pants beat off of it at the same time. So the range of wattage it pulled when running the test was orders of magnitude more than the DTK. And I mean, the thing that was also kind of crazy about this too was when the Mac Pro was doing its compiling, I was noticing like swings in how much power it was drawing in excess of like 200 watts, which is orders of magnitude more than what the DTK pulled at max, which is crazy. So, and the reason why I say that these numbers kind of shocked me was because if you actually look at benchmarks for these two CPUs, whether that's a Geekbench test or it's a like CPU benchmark test, the CPU benchmarks for the dual Xeons in the Mac Pro outperform the A12Z, at least in multi-core. The single-core performance, the A12Z still wins, which isn't all that much of a surprise because it's a lot newer chip, and Xeons are never and were never known for their single-threaded performance. They're always known for their multi-core performance, or being able to, use all their cores that they have, which is why they have so many of them, to, do things like compile code a lot quicker. So I'm not entirely sure exactly why there was such a difference, because it was kind of like a flip. Like if you look at the benchmarks, the Mac Pro seemed like it should be the one outperforming the DTK by like, maybe 15-20% or so, but in reality it was kind of the reverse. Now, I'm assuming part of that is definitely due to the fact that the A12Z's single-threaded score like completely destroys the Mac Pro single-threaded score, and I think that definitely has something to do with it. But when you're talking about compiling code, that is very much a multi-threaded workload, like basically distributing the code, the source files across multiple threads to be all kind of done in parallel. And that's very much a multi-threaded workload. Although I guess, depending on how big your files are, there could be a lot of speed potential advantage in that faster single-threaded performance. But regardless, I was still kind of surprised to see, like I knew that they were going to be fairly close. But I didn't necessarily expect that the DTK would outperform the Mac Pro. So the fact that the A12Z, absolutely just blows away the dual Xeons in terms of single-threaded performance, definitely I think played a role. But yeah, it's just kind of wild to see that this device that was never meant for production and in such a small, essentially kind of 1 liter PC Mac Mini form factor, is able to absolutely destroy my Mac Pro, which honestly has me reconsidering some things on how I want to, because currently the Mac Pro is still, I have it set up as my like main developer workstation. Although after running these tests, I'm kind of having second thoughts because I can get way more performance with the DTK and draw a heck of a lot less power. The only issue, I guess, with the DTK is its display capabilities, because the one thing that is nice about the Mac Pro is I have it plugged into currently it's a dual monitor setup. I have 3 monitors, but the third monitor is a Apple Thunderbolt display, and the Mac Pro, the video card doesn't have Thunderbolt capability, so I can't make use of it, so I'm stuck with only 2. I know, what a hardship. But the part of the issue is actually getting all of those connected up to the DTK. I definitely could probably make it work. It would just potentially be a little interesting. I'd have to kind of move some cables around. So I'm basically just making excuses at this point. So it is definitely something I could do, but again, I would be actually hard limited to 2 displays with the DTK. So I couldn't even plug it into the Thunderbolt display, even if I wanted to, for a couple reasons. One, it only supports up to 2 displays, I believe, and 2, it doesn't have Thunderbolt capability at all, so the Thunderbolt display is out of the question anyway. But, even with that said, I have debated, making it my main machine. The only issue is, since the DTK obviously didn't have a very long life. It was about 6 months. It only is supported up to macOS Big Sur 11. I think 2.3. So if you'll recall back to last week's episode where I was talking about getting my game to build on Big Sur and getting it be compatible with Big Sur, that was the reason. So now you know. But yeah, so that is one potential limitation. And there are some other kind of like quirks with the DTK too, but the main thing is the operating system. And I would like to be running at least on my main machine that I develop for, I would at least like the operating system to be supported and get, regular software updates. Now, currently, the DTK isn't supported under any kind of like open core legacy patcher or anything like that. Although with talking with DOS Dude over the past few weeks, with the whole DTK stuff, which honestly has been absolutely incredible. I actually got the chance to go over to his place and actually see him resurrect one of these DTKs from not working at all, and watching him, solder all the components and get it into working order. So basically the video that he has on his YouTube channel, but just in person, was absolutely incredible. And I saw him actually do it a few different times. He's gotten pretty darn good at getting those things working. But where was I going with this? So in talking with him, it sounds like he has plans to send one of the DTKs that he got working off to the Open Core Legacy patcher developers. So there's potentially a chance that you could see Open Core Legacy patcher support for the DTK, maybe. But I think the more crucial thing that the DTK will provide to the Open Core team is the inevitable time when Apple Silicon Macs start getting dropped, because of course it's only a matter of time. I mean, we're still talking about, Intel Macs being dropped, since currently there are still Intel builds of macOS, and it is honestly a ticking clock for when the last Intel Mac is going to get dropped, which my best guess is the Mac Pro, the 2019 Mac Pro. And I'm trying to remember what my prediction was for when that would get dropped. My guess, I think, was like 2026, 2027, I think was my initial guess. Although with how quickly they're dropping Intel Macs, I mean, who knows? But I'm still kind of thinking that we probably at least have another 2 years, I would say, maybe 3, of the existence of Intel builds for macOS. So the idea, I think, mainly for the DTK is maybe not necessarily getting support for the DTK to be able to run, say, the latest macOS, but at least to understand the Apple Silicon architecture better and to help kind of work on a device that isn't an Apple Silicon device that isn't supported on the latest macOS, and how can you spoof it and do whatever tweaks and add whatever texts and all the things that go into adding support for Macs that aren't currently supported under macOS, how to actually get that support added. So I think it'll definitely be beneficial to the open core community down the line. So there are also are supposedly other plans for the DTK, but those have not come to fruition yet, so I'm just going to keep my mouth shut. But needless to say, I will give you this little tidbit that when the DTK reveal that I'm talking about occurs, you will almost certainly know about it. I'll just leave it at that. So yeah, it's honestly definitely been absolutely fantastic. I'm so blessed to have a friend like DOS Dude. We're good friends, outside, all this stuff with the DTK, and actually having him on the podcast before. I mean, we're good friends. We hang out. And it's always a grand time. Getting to see his, I don't even know what you want to call it. I think Luke Miani's called it a dungeon. One of the RAs back in college called his dorm at the time basically a house of dark web shenanigans. That's not the word they used, but you get the point. it's very much of a lab environment. His roommate and one of my other friends has a full-on 42U server rack. Kind of jealous, but they also have like a complete workstation of like a bunch of different like soldering equipment and electrical equipment that he uses to fix all these parts. And then he's got like this complete row of old computers, like old Macs and all this stuff. It's always a blast to go over there and hang out with them. But anyway, we are definitely getting a little bit off topic here. So bringing it back to the DTK. The funny thing with the DTK that I guess this is kind of one of the last things I'll touch on before we wrap up with our trivia question is I've been looking on eBay at potentially getting an M1 Mac Mini because I had wanted to buy a brand new Mac Mini whenever Apple dropped an M3 series Mac Mini, which has not happened. And from the looks of it, seeing that M4 just got released a couple weeks ago, probably won't happen. So I guess I'm going to be waiting till M4. But I kind of wanted to get on the Apple Silicon, train because the 2012 Mac Mini, as fantastic as it is and how well it served me for, I don't know, like 5-6 years now. It's definitely been fantastic, but it's definitely starting to show its age, which is to be expected. It's over 12 years old at this point. But I had been looking at potentially getting an M1 at Mac Mini specifically for the purpose of using it as a remote dev machine, and kind of like what the DTK is serving right now. Because I'd been looking at the prices and I was noticing that you could easily find, complete base model M1 Mac Minis for under $400, which personally I didn't think was a horrible deal given the performance that M1 has. And for what it's worth, I spent more than that on my 2012 Mac Mini when I first got it. So it was definitely something I was looking into. And I even saw like you could potentially find deals on M1 Mac Minis as low as like under $350. So there were definitely some deals to be had. I just never kind of got around to pulling the trigger on one. But kind of around the same time, that's when DOS Dude came to me and was like, dude, check this out. And I was like, is that a Apple Developer Transition Kit motherboard? And he was like, yeah. And I was like, where on earth did you get that? And, we kind of went through the whole thing. But he showed me like it actually, well, he didn't show the screen of it working, but he plugged it in the boot chime and everything. And it was absolutely fantastic. And I was like, dude, I got to get me one of those. And he's like, oh, don't worry, I'll get you one. So that's kind of how the story of that came around. So it was just kind of a weird coincidence. At the same time that I was looking to try to, get a machine to, build for Apple Silicon and get some ARM builds going, DOS Dude was also, getting these DTKs and that's kind of when he started his process of, tinkering with them and getting them in and working on them and all that. So what better way to develop for a platform than with an actual dev kit itself. And I guess one last thing I'll kind of touch on here, a little bit of, I guess, Apple DTK adjacent, is I also found it wasn't a fantastic deal by any means, on a new in-box Microsoft Windows dev kit as well, which if you're unfamiliar, they had I think they called it Project Volterra. It was back in, I think, 2022 was when they released it. It was the Windows Dev Kit 2023. They still sell them on Microsoft's website, I think, for like $600. But it's a pretty decent machine for what it is. I mean, you get an 8-core ARM chip with like 32 gigs of RAM and a 512 gig SSD. So it's, as far as the specs go, I mean, from my understanding, the CPU performance isn't quite there with the M1, but you get more RAM and you get more storage. So there's kind of a trade-off there. Plus, it's a little bit cheap. Well, I guess they reduced the price of Apple Silicon Mac Minis. But point being, you get, more RAM and more storage. So how I currently have this thing configured, I still have to kind of work on the dev environment since I just got this in literally within a couple days ago. But I got it at least set up where I have a Windows dev environment and then I got Hyper-V set up, so I have a Linux ARM environment also that I'm playing with. And I got the whole remote desktop and remote interface working, so I can actually log into these systems remotely. So it's also sitting in the rack headless, again, part of that home lab reorg that I was talking about with the server rack. So that's ready to go. I just have to make sure you get the dev tools installed and start building some code. So definitely a lot of good things to come. I'm really hyped in order to play around with these dev kits and get some ARM builds going, since up until this point, the only builds I've been able to produce were x86 builds. So I'm really hyped to get these ARM builds going. But I guess the TLDR that I kind of wanted to touch on when talking about the DTK versus Mac Pro performance comparison, because I know there was a lot in there, and some of it might have kind of gone over your head without like graphics to look at, is performance metrics don't necessarily determine everything. So don't necessarily believe all the benchmarks that you see. And I guess one last tidbit I'll throw in here, which I don't think I touched on, is when I was talking about the compiling my own Pokemon game, the DTK took 4.75 seconds. The Mac Pro was 5.87 seconds. And for giggles, because I already had all the code installed and didn't have to do any configuring, I ran it on my 2012 Mac Mini, and it was like 16 seconds. So the 2012 Mac Mini definitely showing its age there, which I guess in fairness, the Mac Pro is older than the Mac Mini, but also at the same time, the Mac Mini was definitely drawing nowhere near almost 600 watts average when doing that code compile for sure. So yeah, lots of fun stuff going on. Like I said, I'll definitely go check out the interview we did with DOS Dude 1 last year, and I'll also try to remember to link to the video that he put out on actually repairing one of these DTKs, so you can see for yourself what all goes into it, because it is quite the Dr. Frankenstein job. Let me tell you, it is quite a piece of work, and it is really cool to see him able to revive one of these things. So with that, let's wrap up with our trivia question for the week. So last week we talked about how Ansible, and how part of Ansible is used and how you write playbooks is in YAML. But what does YAML, or YAML, stand for? If you said YAML ain't markup language, you are correct. So similar to like GNU, the acronym GNU is GNU's not Unix. It's kind of like a recursive acronym. Same thing here. So hopefully some of you got that right. And if you enjoyed this episode, definitely give it a rating and review. Subscribe if you haven't done so already. Leave a like on the video if you're on YouTube. And if you have any questions about this episode, or if you have any topics or comments for future episodes, you can shoot me an email at contact@darkassassinsinc.com. If you're on YouTube, you can leave a comment. Be sure to share this around with friends and family, because I think this was a pretty fun episode. And with that, that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.